All right, so today we're in section 5.6. This will be a semi-short lesson. I just want to teach you really two main concepts from 5.6, and that involves using multiplicative inverses to solve equations. All right, this first slide, you don't have to write down the whole thing. I just need you to write multiplicative inverse is the number's reciprocal. And it can't be 0, obviously. But the multiplicative inverse is the number's reciprocal. It's literally the same thing. Reciprocal and multiplicative inverse are the exact same thing. And we learned yesterday what it means to be the reciprocal. It's basically I'm just flipping the fraction. All right, so just write on your notes, multiplicative inverse is the number's reciprocal. All right, so the multiplicative inverse property says that the product of a number and its multiplicative inverse is going to be 1. And we saw this yesterday in the chart at the beginning of lesson 2. You take 3/5 and you multiply it by 5/3 and your answer will be 1. The same applies with the variable. A over B times B over A equals 1. Assuming that A and B do not equal 0. All right, so it's just this concept of reciprocals. And when you multiply by a reciprocal, it reduces down to 1. All right, so in example 1, when we're solving a one-step equation, we must use reciprocals to get x by itself. 4/7 and x are connected. How can I isolate x? Well, I need to multiply by the reciprocal. And what you need to realize is when I cross-reduce this, it does not cancel out to 0. Cross-reducing my 7s and my 4s actually reduces everything down to 1. But we do know, so these are all 1s, we do know that 1x is the same thing as x, right? All right, so 1x and x is the same thing. So now, yes, our x is the same, our x is by itself, isolated. But whatever I do to one side, since I multiplied the left side by 7/4, I must now multiply the right side by 7/4. Look for opportunities to cross-reduce. That makes multiplying a little easier. Can I cross-reduce anything?
Yes, the 12 and the 4.
Not the 12 and the 4. The negative 12 and the 4. We want to identify 12 as being negative, so that will help us to remember that my reduced value also needs to be negative. All right, so now x equals negative 21. I just simply multiply. Now, your book is going to suggest that you check your answers on your homework. Checking is going to be optional. However, I do want to show you that you can do it the exact same way as we checked with equations back in chapter 3. We can plug it in. 4/7 times negative 21 equals negative 12. All right, so now actually put that in your calculator. 4/7 times negative 21. You need to actually check. So every year I see someone actually show a checked answer and it looks like it works out, but it's the wrong solution. And the reason they do that is because they don't actually put it in their calculator. They're just following the steps. They're not actually checking. All right? Well, checking is for your benefit, so you can be 100% sure that you got the answer correct. All right? So yes, when you multiply it, it equals out, okay, and it checks out. So try to solve the second one now. We need to isolate x. We need to get x by itself. So what must we multiply both sides by in order to get x by itself? And then what would be our answer? Okay, so what do I need to multiply by to get the x by itself? Negative 9/5. If there's a negative attached to the x, you must multiply by a negative in order to take it with you to the other side. We cannot leave our variable negative. So now they cross-reduce, but do they cross-reduce to 0? No. They cross-reduce to 1. And now x is by itself equals negative 15 over 1 times negative 9 over 5. Can I cross-reduce anything?
Yes, the 5 and 15.
5 and 15. Notice I leave my reduced value negative. That helps me remember that it's negative, so I'm not just relying on the original. All right, so now negative 3 times negative 9.
Equals
Is it negative 27?
positive.
It is positive 27 because remember, I multiplied two negatives together. 2 is even, and an even number of negatives is a positive answer. All right, go back and check. And negative 5 over 9 times positive 27 would give me negative 15. Again, checking will be optional on your homework, quiz, and test. It is not going to be counted against you if you don't check, but it's a good idea because you can be sure that you were right. Okay, in example 2, now I'm solving a two-step equation. Actually, real quick, I want to back up to example 1. How many fractions do you see here in example 1? How many fractions do you see in each equation? How many do you see? One fraction per equation. Now, in example 2, how many fractions do you see per equation? 3. You see multiple. So now when you have multiple fractions, you have two choices. In 5.6, they teach us to solve with these fractions by finding the LCD and actually physically converting these fractions using the LCD. In 5.7, they teach a method called clearing fractions. I do feel that clearing fractions is a much easier way of solving these. So my choice is to teach you the clearing fractions method to kind of try to reduce as much confusion as possible. Okay? So we're just going to stick with that method, and you just have to trust me that it helps eliminate some common problems that we would have in solving these problems. Sound good? All right, so here's what we do. We still need to find the LCD of our denominators, but we can do that using mental math. We don't need to show any work for that part. What is going to be the LCD of these three denominators?
15.
It's going to be 15. So here's what we need to do now. In order to clear the fractions, we are going to multiply each fraction by 15. Each fraction by 15. All right? And when I cross-reduce, it's going to be different for each fraction depending on their denominator. For example, in the first fraction, the 15s cross-reduce down to 1. Right? 15 cancels and 15 cancels down to 1. And so now 1 times negative 11 is negative 11x. Well, on the second fraction, what would it reduce down to? 3, right? So 5 and 15 reduces down to 3. And what is 4 times 3? 12. So now it's plus 12. Equals, what do 3 and 15 reduce down to? 1 and 5. So now I've successfully canceled out all my denominators, and now I'm left with a two-step equation, a standard two-step equation. So I need to remember, what is the first step that I take when I'm solving a two-step equation?
Get rid of stuff not attached to the variable.
Very good. Not attached to the variable, which would mean to subtract 12 from both sides. So negative 11x equals negative 7. And now I'm on the home stretch. I need to solve for x. So what would I do to both sides?
Divide by negative 11.
Mm-hmm. And what would be negative 7 divided by negative 11? Keep it a fraction. Is my answer positive or negative? I'm dividing how many negatives? 2. 2 is even, so my answer is positive 7/11. Because the original equation started with fractions, I'm going to leave my answer as a fraction also. And another thing I want to point out is these answers are not going to be exact. They're not going to be whole numbers, and I would almost say ever, okay? So, and that's okay. That's not a big deal. We can handle that. All right, so now I want you to look at the second one, the second equation, and go ahead and you have to start by finding your LCD. Well, this one isn't going to be as straight forward as the last one because none of these three numbers are my LCD, okay? Because 6 does not go into 27. 27 cannot be my LCD. So what number would I start with when I'm listing my multiples to find LCD? The largest one, 27. So now go to the next multiple of 27. 54. Does 9 go into 54?
Yes.
Does 6 go into 54?
Yes.
So that's your LCD. Now I want you to go ahead and clear your fractions. All right, so 54 was my LCD, so I'm going to multiply each fraction by 54. So 27 and 54 reduced down to what? 2. So 2 times 10x would be 20x. Minus 9 and 54 reduced down to 6. So negative 3 times 6 is negative 18. And then 6 and 54 reduced down to 9. So negative 1 times 9 is negative 9. Who got this equation once you cleared your fractions? Okay. Do you see where you went wrong? If you missed it? Okay. All right. So now what do you do next? Add 18 to both sides. 20x equals 9. Divide both sides by 20, and x equals 9 over 20. All right, who got it right? 9 over 20. Okay, so we're going to do one more of these. But we are now going to go ahead and transition over to section 5.7. It's all part of the same lesson. Sections 5.6 and 5.7 are essentially the same thing, especially since we're only using this one method to clear the fractions. Right. So in the last example, again, we're continuing on with this concept of clearing fractions. I want you to do this one start to finish. Find your LCD, clear each individual fraction, cross-reduce, and then solve the two-step equation. Okay, what's my LCD?
12.
LCD is 12. Did you multiply each individual fraction by 12?
Yes.
Did you do that? So 12 and 6 reduced to 2. 2 times negative 5x is negative 10x. Did you put negative 10x?
Yes.
Okay. Now 2 and 12 reduced to 6. 1 times 6 is 6. 3 and 12, or 4 and 12 reduced to 3, and 3 times 3 is 9. Who got that equation? Okay, so we're doing better. All right, now what do I do to both sides first? Subtract 6. Now what do I do to both sides? Divide by negative 10. X equals negative 3 over 10. All right, who got it right? Negative 3 over 10. Okay, doing much, much better. All right, so now moving on to example 2, I'm going to clear decimals now. Clearing decimals. We talked briefly about this yesterday, clearing decimals. And the way we do that is by finding the term in the equation that has the most number of decimal places and what decimal place that number ends in, okay? So in the first one, it goes to the tenths. In the second one, the hundredths. And the third one, the tenths. So we can clearly see that the second term has the most number of decimal places. All right, and what decimal place is it? The hundredths. So I must now multiply every term in the equation by 100. Okay, in order to fully clear all of these decimals. And what I'm doing here is I'm moving my decimal to the right 2 places. So on the first number, that would mean adding 1 0 after the 3 because there's already 1 decimal place in the original number. I add 1 more 0, and now I've cleared that decimal, and it's now 230. On the second term, what would be my new number after the cleared decimal?
5,000.
No, 514. I don't need any zeros after the 14 because there's already 2 decimal places in the original number. Guys, if you're struggling with that, just put it in your calculator. 5.14 times 100. Now for 0.8, already 1 decimal place in the original number, how many zeros after the 8 need to be added? Just 1, because I need to go 2 decimal places. So now it's going to be 80m. And I've now successfully cleared all of my decimals and I can solve for m. Well, how would I do that? What's my first step? Subtract what? 514 from both sides. Negative 284 equals 80m. And now what would I do? Divide both sides by 80. And my answer, it does make sense to leave it in a decimal since my original equation was written in decimal form. So whatever my original equation is in, that's kind of what I just leave my answer in. If it's a fraction, I leave it a fraction. If it's a decimal, I leave it a decimal. All right, go ahead and try to clear the second equation now of all of your decimals. Figure out, do you need to multiply the whole thing by 10, whole thing by 100, 1,000? What does it need to be? Okay, so clearing the decimals out, what did I have to multiply everything by? 100. Very good. 100 each one. All right, and then we get 723, 410, and 50. All right, who came up with that equation? Who got it? Okay, so that's one of the hardest parts. Now it's kind of more the downslope of things. I'm just solving the 2-step equation by first subtracting 410, and I get 313 equals 50m. Divide both sides by 50, and there's my answer, 6.26. All right, and that should be it for clearing decimals. So now example 3. In example 3, we're solving an inequality with fractions. Here's our word problem scenario. A sign in a clothing store says to take 1/3 off the marked price of a shirt. You have $20 in cash and a $5 certificate. What are the original prices of the shirts you can afford to buy? So the first thing you need to decide is what is your total or how much money do you have on hand?
25.
Technically 25, but you have $20. $20 cash. So $20 is going to be your starting point. We always try to start with our total, okay? Which in this case is $20. And now I have to decide what inequality am I going to use? Does the total of the other information need to be less than $20 or greater than $20 in order for the problem to work? Less, right? You want to get up to the cashier to pay and actually have enough money to buy your shirt, right? So the cost of the shirt needs to be less than $20. But let me ask you this. If the cashier says your total is $20 exactly, do you have enough money?
No.
Yes, you have $20. So it can be equal to. Okay, so that's the thought process you need to go through. Now we have the challenging part. It says, what are the original prices of the shirts you can afford to buy? Obviously, we're looking for a cutoff amount. I can afford to buy a shirt that's this much or less. Okay, I'm looking for that cutoff. But I don't know what the original price is. Would you agree? So that is my variable because I don't know what it is. But it also says that you can take how much off of said price that you don't know yet. How much? 1/3 off of that price. So that is another part of this inequality. But do you see why it also has a P? Because it's 1/3 of that price that I don't know yet. Okay? And then you have one last piece. Plus 5. Technically, it's going to be -5 though because you're going to need to add it to the other side. So since you know you have to add 5, you have to subtract it because that's the opposite operation. All right, another way to think of that is you're going to subtract $5 more from the price of the shirt to get you to how much cash you have to come out of pocket with. Okay? So now you are ready to solve, to start solving. But before you do that, we have this pesky fraction here in the middle. So you have 2 options here. You can find an LCD and create equivalent fractions, which is not the method that we've chosen. Or you can clear the fraction. All right, so we have to deal with that. But before we do that, we're going to move what is not connected to the variable to the other side. So we add 5 to both sides, and now we get p minus 1/3 p is less than or equal to 25. So again, whatever's in my denominator, I can multiply every term in the inequality by that number to clear the fraction. All right, go ahead and kind of get caught up on that, and I want you to go ahead and clear the fractions and rewrite your inequality. All right, so now I have 3p minus p is less than or equal to 75. I'm getting closer. What's 3p minus p? No. 2p. 2p is less than or equal to 75, and I'm really close now. What do? Divide both sides by 2. So here's what we're saying. The price of your shirt needs to be originally $37.50 or less in order for you to have enough money to buy it, for it to be $20 cash or less. All right, so we're going to do another one of those. I'm going to help you set up your homework problem where it's kind of dealing with that same type of thing. It's really going to come down to, once we practice a few, it will be easier to kind of identify the different parts of the inequality. All right, you got it? Okay, now example 4. Well, compared to example 3, you may find example 4 to be a little easier. Solving an inequality by clearing fractions. The good news is, well, one good news is we're only going to do one of these, but the other good news is that we solve it using the same strategy that we use to solve or to clear fractions with an equation. We need to find the LCD and then clear each one of the fractions using the LCD. All right, so go ahead and try to do that. What is my LCD?
16.
Well, it's not 16, but if you use 16, you would still clear it. Your LCD is 8.
Yes.
It is conveniently going to be 8, since my middle one's going to completely cancel. All right, so 8 and 4 cross-reduce to 1 and 2. 2 times negative 3 is what? Negative 6. Okay, and then my 8's completely reduced, so that's just going to be minus 1. Is less than or equal to, what's negative 1 times 2? Negative 2. All right, and now I'm ready to solve my inequality. Go ahead and solve this 2-step inequality. Okay, so what do I do next? Add 1 on both sides. Negative 6m is less than or equal to negative 1. Now what do?
Divide by negative 6.
Divide by negative 6. What is my answer?
1/6.
It is positive 1/6. Is m less than or greater than or equal to?
Greater than equal to.
Why greater? Is it greater or less?
Greater.
Why greater?
It just is.
Because there was a negative connected to the variable. Did you catch it? You have to flip the sign because there was a negative connected to the variable that you had to divide by. So it's now greater than. And if you understand that, that's everything you need to know for the rest of chapter 5.